Hi guys, we left off with our electron configurations. We started out using this as our training wheels as we filled up each sub-level going out from energy level 1 all the way up to energy level 4. And then we learned that we can use this diagram to figure out how to fill up the various orbitals in the correct order. So what we're going to do today is we're going to use this order of 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. We're going to use this to do a second type of notation, which is called the orbital notation. So what we learned last time is electron configurations, and they look like this. What we're going to do today looks different, but it still shows us where the electrons are at. So we are going to use this diagram here, and we have to start at the bottom here. Ignore this gap in between. So what this is the same order. So our energy level is increasing this way. This is energy going up, and each line is representing an orientation, okay? So this is our S, this is our sphere, okay? And every energy level has that spherical shape. We're not going to draw the spheres. I'm going to go back and erase those actually. But that's what the line is representing, is our spheres. Then we have my p orbitals, okay? And the p orbitals, remember we had px, py, and then pz was coming out and going back into the board. So they're in 3 dimensions. That's what each line is representing. And how many electrons fit into each of these orientations? If you said 2 electrons fit in each, you are correct. So that's 2p. 3p would be up here like this. Okay, they look the same. They're just a little bit farther from the nucleus, so it's in a higher energy level. Okay, and again, we're not actually going to draw the shapes. What we are going to draw are the electrons in there. Okay, so we're going to draw the electrons in each energy level and in each orientation. And we're going to draw them using arrows. So let's look at some examples. Let's do the same examples as last time. So we'll do chlorine, bromine, and sulfur. Let's start with sulfur because it's the smallest one. Sulfur has 16 electrons. Here's our electron configuration from last time. But we don't really need that. What we're going to do is we're going to use this picture to add our electrons to each line. 1 spin up and 1 spin down, and we're going to fill up each line until we get to 16. So I just drew 4 arrows. That represents 4 electrons. I stopped because we have 3 possible orientations for the p orbitals, and I wanted to show you that I'm going to put 1 in each orientation before I pair them up. That will be really important when we get to bigger atoms or when we start talking about magnetism. Okay, so I have 2, 4, 5, 6, 7 electrons. We had 16 to draw. So now I have to pair them up before I can move up. In energy, these have to be filled. Okay, so pair these up. And 2, 4, 6, 8, 10. There's 12, 13, 14, 15. And that last electron, the 16th electron, is going to go right here. So this orbital notation tells us something that the electron configurations didn't tell. The orbital notation will tell us, so see, this told us that I had 4 electrons in the 3p orbitals. Okay, the sulfur ends with 3p4, so the top one is 3p4. Let's look down here. Do you guys see how there are 4 electrons in the 3p orbitals? But the orbital notation shows us something really important. These last 2 electrons are unpaired. They're lonely. And those unpaired electrons want to be filled for it to be a stable atom. So I can see from this orbital notation that sulfur wants to make 2 bonds. It wants to pair up these 2 electrons that have no partner to them. Okay, so that's why this orbital notation is really important. So I've drawn 16 electrons. This is the orbital notation of sulfur. If the question on the test asked you to draw the orbital notation, you would actually redraw this like so. 3 lines for the p orbitals, 3s, and then 3 lines for the 3p. I'm going to use a different color for the electrons now. 1, 2, 3. Get in the habit of putting them in their own before you pair them up. Okay, 1, 2, 3, and 4. So you would draw this for the orbital notation of sulfur. Okay. I'm just going to carry on from there. So what we had next is chlorine. Chlorine has 17 electrons. What does that mean? That means that down here, if I were to just add 1 more electron, now I have the orbital notation for, let's add that electron right here. Now I have the orbital notation for chlorine. And how many bonds does chlorine want to make? If you said 1, you are absolutely correct. It wants to pair up that 1 lonely outer electron. And when all of those p orbitals are filled completely, it lowers the energy, the potential energy of the atom, and makes it a much more stable atom. So that's why chlorine is always going to look for that last electron. It's going to steal it from wherever it can. Okay, our last example is going to be bromine, which had 35 electrons. We should end in the 4p orbitals. Okay, so let's keep that in mind. 4p5 is where we're going to end. Okay, so I had 17, there's 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and 35. Okay, so how many electrons are in the 4p orbitals? There's 5 total electrons in the 4p orbitals. And how many unpaired electrons? There's 1 unpaired electron. It's going to make 1 bond. Okay, bromine is right below chlorine on the periodic table. So you'll notice that both chlorine and bromine have this 5 at the end, and they both have the p orbitals as their outermost orbitals. Okay, that's not a coincidence. That's why the periodic table is set up the way it is. The only difference is chlorine is in period 3, I can tell by this number here, and bromine is in period 4 on the periodic table. Okay, so this is orbital notation. You just draw arrows up and down representing the electrons, filling from the bottom up until you run out of electrons. And lastly, the noble gas notation. This will not be on the test, but I wanted to quickly go over it for those of you that might be interested. So for these, it's just a shorthand way of writing the electron configurations. What you do is you have to use the periodic table. You're going to use the periodic table and you're going to look at the noble gas, that's group 18, that comes directly before the element, not after, but before the element. And you're going to write that noble gas. And then using the periodic table, you're going to add the last part of the electron configurations. So calcium has, calcium's right here. It has argon as the noble gas directly before it. So argon has 18 electrons in it. So over here, I'm going to write argon with its 18 electrons already included. And since calcium has 20 electrons, I have 2 more electrons to place. Here's the cool thing. The periodic table tells us what electrons come next. So over here, calcium, it's in this first section of the periodic table. We call these first 2 groups the S block. Okay, so it's in the S block. That means it ends with S orbitals. And the period, like I just told you guys, the period tells us what energy level. So it's going to end with 4S, and then you count how many spaces over to know how many electrons are in that orbital. So this would be 4S1, potassium. Calcium is 4S2. So we're going to write argon with a 4S2 is the noble gas notation for calcium. Excuse me. Okay, And we're going to ignore that. So let's do chlorine. And then I'm going to stop there. Chlorine is number 17 on the periodic table. The noble gas before chlorine is neon. Argon comes after because it's number 18. So neon comes before. Neon is number 10. So Ne for neon plus, so it has 10. Chlorine has 7 more electrons after that. And where are they? Looking at the periodic table, you will see that you go down to 3S. After neon, right here, this guy, after neon, you come down to sodium, 3S. And you're going to have to cross the S block in order to get to chlorine over here. We're reading left to right. So it would be 3S2, that will be filled first, 3S2. And following 3S, I come all the way over here to, this is the P block now, from boron to fluorine and all the way down. This is the P block, so I'm filling up the 3p orbitals now. So this would be P1, 3p1, 3p2, 3p3, 3p4, and 3p5. 3p5. So this is the shorthand, the noble gas notation of the electron configuration. Let's focus on this last little part, 3p5, because we did chlorine up here. Let's see if it matches. Should it end with 3p5 for chlorine? And yes, it does. It ends with 3p5. All right, so that is noble gas notation. The noble gas notation will not be on the test, but it is good to know. Have a great day.